Okay, thank you so much for the invitation to my first PromCon. Super excited to be here. As you see, the talk is called Alertmanager has Amnesia, with the hidden subheading, Shall We Fix It? I realized that that's a bit of a provocative heading, so I removed it, and you'll see why at the end of the talk. I'm doing this, there's a QR code there, like if you want to, you can scan it and like follow along on your phone. I've never tried that before, but it's up to you. You can also follow it here. Okay, a bit of background to this talk. So I'm a systems engineer at Open Systems, but only for the next week or so. I'm actually leaving. So this is a bit of a kind of cathartic talk where I sort of write my memoirs about my time with Alertmanager. It's one of the tools that we introduced to our stack. It was a big change, it was a big migration. And I don't think there's any colleagues of mine in here, but I'm not sure I could honestly say it would be 100% good feedback. But it was, we introduced some cool new stuff. So yeah, this talk is really about kind of digging into what Alertmanager does, finding a few kind of gotchas, and at the end, I'll sort of introduce a kind of a hacky thing that we did just to sort of open the discussion as to sort of the future of where Alertmanager can go. Okay, so who's actually had like direct experience working with Alertmanager, kind of like an end user, like an operator? I see a few hands. Okay, yeah, that's good actually, that's good. So this will be like revision for most of you, but then also I think the rest of you, this is kind of interesting to see like a user's perspective of what it's like to work with Alertmanager. So what does it do? I mean, it manages alerts. Like, what does that mean? So, for example, in our production system, we have maybe 10,000 alerts firing, sometimes even more. If every single one of those alerts resulted in a notification that you had to do something about, you'd basically spend your entire day responding and triaging alerts. So Alertmanager is all about grouping alerts to make the number of notifications that you get manageable. It's about routing, so making sure that the right team gets notified when their service is broken. And you can also do other fancier things like inhibition and silencing, which we'll dive into much later. At Open Systems, we're big Thanos users. I've given a few talks on our Thanos setup in the past. And we are collecting data from lots of hosts. I mean, maybe some of you will laugh, it's 10,000 hosts sort of around the world. But that's why we have Thanos, and we have kind of centrally evaluated about 2,000 alerting rules. And we run this in a platform self-service manner, so teams can kind of onboard their own rules. You kind of know where that's going. You're at the mercy of your users in that case, because they can really do whatever they like. We also have an alert manager that's also managed in a kind of self-service approach, so users can define their own inhibitions. And typically, that alert manager instance will be handling about 3,000 firing alerts. On the right-hand side, we have the typical receivers that we're talking to. So we have Slack, that's kind of like for internal alerting. And then we have the important stuff, which is the customer-facing alerting. So we have a custom application called Alert Handler. And this is basically a webhook receiver for the Alert Manager, and that's plugged into our mission control network operations center. That means that if something goes through Alert Handler, pretty much it's going to end up in a customer-facing ticket. And so if Alert Handler or if Alert Manager has problems, it can be very noisy. So this is a picture of like our public display of what's going on in mission control. That was a bad day. Typically, you'd see like 50 tickets maybe, and this is like 2,000, so yeah, that was not good. But what we've kind of noticed is that there are some patterns in the noise that you see. So we found that like Tuesdays were particularly noisy for kind of complaints about alerting. I should also mention that the alert handler, we don't just let this happen, right? We've actually built in some custom logic. We have like a rate limiter. We have, quarantine. We call it quarantine, basically. So when it looks like something's going wrong, it can kind of batten down the hatches and stop anything getting to the network center. But that obviously can fail. So yeah, Tuesdays are interesting. So what happens on Tuesdays? Most of our workloads, they actually run on Azure Kubernetes service. So basically every Tuesday, that's when they do like a rolling node restart, every 2 weeks maybe sometimes. And of course, we design our applications on Kubernetes that they can handle that gracefully. But sometimes they don't. So sometimes what we notice basically is every time Alert Manager reboots, we got a flood of alerts and a lot of complaints. And yeah, it wasn't just about the node restarts. Basically every time we looked at Alert Manager, yeah, it had this kind of effect. So like version upgrade or a config upgrade or something like that. So yeah, we kind of had no option but to dig into it and sort of learn how Alertmanager actually worked. That's why I'm here today, to share with you what we found. It is available, but this sort of, I think it's a slightly misunderstood application. So I think it's nice to have it was nice for me actually to put this together and like say, okay, this is how my understanding of this is, and maybe it's useful for some people in the future. Okay, this is the basic Alertmanager workflow. You have an API, and you can do two things with that API that we really care about. You can fire an alert, so you send an alert to the Alertmanager, and that then goes through into an alert store here. I think if I do this, you might be able to see my, okay, we won't do that. You can see on the top, you see the alert store. That's held in memory, that's important. That then goes through to a dispatcher and a notification pipeline, and at the end of the whole thing, you get notifications in the backends of your choice. Great thing about Alertmanager, it has a lot of integrations. So anything you can think of, there's probably a built-in receiver for it. If you don't have it, like we built a custom thing, you can also just do like a generic webhook, and it's very easy to set that up. We also have the silences. So if you know that some label or alert is noisy, you can fire off a silence to the API. That then inhibits, or that not inhibits, it's the wrong word to use. That basically prevents the alert from going through the notification pipeline. And then you also have this notification log. That's the persisted store of which alerts have been sent or which notifications have been sent. So the coloring is kind of suggestive. The dark colors, those guys you can opt in to persist. That means that they survive reboots. But the alert store, that's actually only held in memory. That means that every time the Alertmanager is rebooted, for whatever reason, that store goes away. So the Alertmanager comes back and has amnesia. It doesn't know what's going on. But that's not a problem, as we'll see. It's actually a design choice. OK. I think we can very quickly just run through some animations of how this actually works. So like there's basically two important parts. First is the dispatcher, and the next is the notification pipeline. So when you fire an alert into the Alertmanager, let's say you have some labels on that alert, right? It comes from a metric. The first thing that the Alertmanager will do is it will group by some configured set of labels. So let's say we're grouping by service. Because there's no service, there's no group already existing, a new group will be created, and the alert will be added to the group, and then a timer will start called group wait. That's the initial time that the Alertmanager will wait for before it does anything with that alert, right? So it's sort of a buffer period. As group wait kind of ticks, the alert will be flushed to the notification pipeline after the end of the group wait. Now, then comes in another timer called the group interval. This is typically longer than the group wait, and this will just keep on ticking. And at the end of every group interval, those alerts will be flushed again in that group to the notification pipeline. Now let's imagine that another alert comes in. So it's the same service foo. That means it's going to be added to the same group. That's the beauty of group by, so that now we have sort of one batch of notifications which will be sent downstream. And when that's added, it actually resets the group interval. So if we're in the middle of a group interval, when we add an alert to the page, we'll actually reset that group interval. Then we continue, the group interval comes through, we get another flush, and now we'll have a new notification in the pipeline to handle. Just for completeness, let's see what happens when a new service has an alert firing. It will be added to another group and with a separate sort of concurrently running ticker or timer. OK, so that's how the dispatcher works. Once the alerts have been flushed from the dispatcher, then we're onto the notification pipeline. So there's several steps which the alerts have to overcome in order to get through to your endpoints. The first step is inhibition. So this is where you can basically configure in your Alertmanager config that if an alert with these labels is firing, then don't let these alerts have notifications. So it's a way of saying, it's basically a way of scoping alerts. I've got an example of that later, you'll see it. Then you actually check the persisted silence store to say, hey, does this match any sort of known silences? If those two checks are fine, then we actually forward them to the routing stage. And the routing stage is configured by users to say, hey, when these guys are firing, I need to get an alert in my Slack channel or my mission control ticket, whatever. So we basically fan out those alerts. Now the alert manager has to decide whether it's going to forward those notifications. So there's two steps. Well, actually just one step. There's a deduplication step. And what happens is that this notification log, which was previously mentioned, it's basically a list of alert fingerprints, which is unique hashes of labels. And it basically checks, should I send this alert? Has a notification already been sent? If a notification has already been sent, how long ago was that notification sent? Is it longer than the repeat interval? And typically you'd set a repeat interval of like 3 hours maybe. You want to get pinged every 3 hours if something is still burning. More critical, you can make it smaller. But the alert manager decides whether or not it's going to ship the alert. If it does, it goes through to a retry stage, and it gets through to your endpoints in the end. So that's how the alert manager works. Back to Noisy Tuesdays. We kind of dug into this a little bit, and we sort of said, hey, which alerts are actually firing here? What's the problem? Like, is there some pattern that we can find? And it turned out that in our situation, we got a lot of these host down and cluster down alerts. So those guys should actually have been inhibited because there's kind of higher order scopings which should have been covered. So that's the second kind of observation which we made. Now, just to quickly run you down how we model alerts at Open Systems. So we're running, we run remote hosts for our customers, network hosts. And they're typically clustered for kind of high availability. So if we're thinking about what we actually ship and what we're monitoring, this is it. It's just a server rack, basically. So this is like a host, and then multiple hosts form a cluster. So if a host has a problem, then we want to know about it. That generates one ticket in mission control, which is a host down ticket. If the whole rack has a problem, then we could, of course, generate 3 tickets, but that's a bit noisy because then an engineer in the NOC has to go join them together. It's just toil. So yeah, we have a scope. We basically say that the cluster is down, right? So that the cluster down inhibits the host down alerts, which are also firing because those guys are also out. We have another concept, which is a site. So there can be multiple clusters at big sites, right? Big, lots of network traffic. We need multiple proxies or whatever. So that's another kind of another concept that we have. So of course, we can go through the same exercise. We can have 6 tickets, we can have 2 clusters down, or we can just have a single site down with the inhibition rules in place. Right, so that sets the scene for kind of the problem. So what happens during the reboot? As I've already hinted, the silences are restored from the disk. The notification log is restored. So the alert manager knows what it shouldn't send, and it knows what it has already sent. What it doesn't know is the current state of the world. It doesn't know what the current set of alerts that are firing. It has to recover from this kind of amnesia which it has. And the way it does that, it's actually, like I said, it's a design choice, because typically you plug in upstream rulers to your alert manager. So Thanos, Prometheus, I know for sure those 2 guys do it. So if we use Thanos. And so Thanos, it's basically every 60 seconds evaluating these alerts, and it's constantly shipping those alerts. That means that within, say, about 2 minutes, the alert manager should have the same picture of the world again when it comes back. So as long as you have to be a bit careful, and this is where you're at the mercy of your users. If you configure like a group wait at 5 seconds, you're probably going to have a bad time. So this is where sort of documentation and teaching comes in, but that's not very effective most of the time. So over the time, as long as you give Alert Manager enough time to sort of rebuild the groups in memory and collect all the alerts coming in, you won't have problems. The issue comes really when you have funny configurations that you can't really control. To give you a bit more of a concrete example of what's going on here. So let's consider that we have a cluster down alert firing. So every tick, 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 we get these alerts coming from Thanos. And let's imagine that we also have a host down, right? So imagine this scope scenario where we have the host down, we have the cluster down. Now, what happens in the good case? We have the group wait. That then emits a notification that gets sent to mission control. No problem, that's great. Then we have the group wait for the host down, and because of the inhibition, that gets blocked, that gets stopped. This is perfect. This is exactly the behavior that we want. But now consider what happens in the uptime of the alert manager. If we have a reboot, just beyond this, so basically we have a reboot in between the cluster down and the host down arriving. That's a problem, because what's happened here is that we've lost the in-memory state of this cluster down. And that means that when the host down comes in, we have another group wait, and we actually end up with a flood of notifications in mission control. So congratulations, you've now got a lot of complaints, and you have to go and deal with that. Yeah, that happens. So maybe a highly available setup will plug that gap and save us. Okay, so here be dragons. Highly available alert manager. So you might think you can just go ahead and say spin up three replicas. It's not that simple, unfortunately, because each of those guys is just going to be working independently. They've got their own silence store, they've got their own notification log, they've got their own view of the world, right? They need to talk to each other somehow. So if someone calls the silence endpoint, maybe only the top guy knows about the silence and the bottom two don't have a clue, so they're just going to ship those notifications, right? Or even worse, if one of the replicas decides to send a notification, how do the other guys know that they shouldn't send it, that it's already been sent? And the way this is solved is with the gossip protocol. So the alert managers form a gossip cluster. They gossip with UDP, and they basically make sure that the silence and the notification log is kept in sync across the cluster. And this works really well. Alerts are not gossiped, perhaps surprisingly. So that means that the Thanos, the ruler clients, they have to be configured to ship the alerts to all the members of the cluster. This is very, very important. This is something which I see quite a lot in sort of GitHub issues and stuff like that. You really must make sure that your rulers are sending not even to a cluster IP or a load balanced endpoint. It has to be to every replica. And so that means that you have individual groups, group weights, etc., sort of tickers going in each of these alert managers. Now there is another problem here, because in this picture that we have, you would still be susceptible to the duplication problem, right? So, or rather, let's not say it's a duplication problem, it's a race condition, right? If all of these guys decide at the same time they want to ship a notification, how do you make sure that you don't end up with 3, right? Even though they are syncing the notification log. This is the next step. So then we have to revisit the notification pipeline. And there's 2 additions which we have, 2 extra steps which we need to go through when we're working in the cluster mode. The first, we just have to check that the gossip is settled. We have to check that this knowledge sharing that's going on is in a happy state. And this is usually important on a reboot. So when you reboot the alert manager, there is a big flood and noise of gossip all going around. So this is usually, this is only usually a blocking step at the beginning of the process. Then you have your, the steps that we've already talked about. And when we get to the routing step, there is an additional wait component. And the alert managers each have to decide if it's their turn to ship notifications. And when they decide that now is my turn, then they'll go through the whole dedupe step, they'll check the NF log, and of course, if their partner or another member has already sent the notification, the NF log will be updated, therefore they don't send anything. But because they've waited, they've kind of avoided this race condition. And yeah, in theory, we get nice deduplicated notifications in our backends. The last piece of the puzzle is fixing this race condition. So what the replicas do is they form an order. So they give themselves just a number like 0, 1, and 2. And so the 0th one is the leader. They go first. The first one goes second. The second one goes second, and so on and so forth. You can actually see this in metrics. So there's a metric which is I didn't put the metric here. There is a metric called Alertmanager peer number, I think, maybe something like that. So you can actually see what happens during a reboot. What basically happens is you can see that in this picture, the yellow replica was the leader first, and then the green replica, and then the blue replica. Then the yellow replica was rebooted, therefore the green replica took over, and sort of you can see how these numbers kind of click down as a reboot goes on. This is nice behavior of Alert Manager. That's a well-behaved cluster. Now, how do we actually use that to prevent duplicates? You just have to remember this iconic scene in Breaking Bad. There's basically a sort of a talking pillow that the alert managers hand around to one another, and they take turns. And this is governed by another timer, which is called the peer timeout. This is typically about 15 seconds. So after 15 seconds, the alert manager 0 will hand the talking pillow to the first replica. This guy will take take care of sending notifications for a brief time, and then the next guy will take care of sending notifications, all the while gossiping, all the while updating the NF log, and so on and so forth. Now, after all that, did it help us? Not really, unfortunately. So, yeah, this was really the puzzling thing. And I struggled a lot with this because I see that kind of theoretically it does work. But at the same time, my background is experimental physics. So I'm aware that life just doesn't work like that. Particularly when you move to distributed systems. So yeah, so what are we looking at here? We've basically got the, this is a rollout. This is a picture of a Alertmanager cluster during a rollout. And on the bottom, we have a metric which we own. This is from the alert handler. And this is the number of events which are stored in our quarantine. So this is basically a good measure of if we screwed up, basically. If that thing spikes, then we screwed up. So what we see is that we have a lot of alerts at the start, like 3,000, like I was talking about. That's a typical number for our production system. And then we see 2 replicas go away very quickly, and they come back. And then there's sort of a gradual, and this is, if you look at the x-axis, this is over an order of minutes. There's a gradual sort of increase in the number of alerts which are being stored in the system. And at some point, after about, I think after about the 3rd replica disappears, that's when the quarantine spikes. Boom, it's there. The notifications have fired again. So it's kind of suspicious that it takes so long for the cluster to recover after the reboot, because we saw that it should be back within about 2 minutes. So we kind of, just within the team, we sort of threw around these ideas, like, what if we can bring this time down, right? Like, we don't really understand why that time is so long, but what if we can just bring that time down? The hypothesis was purely experimental. Maybe if we bring that time down, the cluster will stabilize quicker, and therefore we have less noise. That might be good. So yeah, that was the basis of a kind of hackathon project, which we did. We ran that back in July. It wasn't the only hackathon project. We had many, like 20 submissions. But a lot of people jumped on this project, no idea why. It's kind of famous in open systems, or infamous. So the plan was this, basically. It was very, very hacky. It was 2 days. Let's just try putting a sort of distributed store or a shared store for the alerts, and see what happens. See if that kind of helps when we reboot the Alertmanager. So now we have a plan. We just kind of need to figure out what to do. That was the hard bit, how to actually do the plan. So of course, we live in the modern age, and what else are you going to do but ask Claude to do it for you? So this was basically what the hackathon team did. Yeah, so, I mean, that was the actual prompt, I think. Just to recuse myself here, I was really the sort of the PO of this project. I wasn't on the dev team or anything. I was just sort of managing from afar. What was funny was that 20 minutes before code freeze, the team was super happy, and they were like, "We did it! We persisted the notification log." And I was like, "Guys, that's already persisted. Like, you're supposed to persist the alert." So then they had 20 minutes of rapid vibe. But they actually did it before code freeze. It was very impressive. Well, impressive. 3,000 lines of slop. You can find it, actually. We have our open source Alertmanager if you want to go and laugh. It's very funny. Then we let an actual human take over. So it was useful in the end. We took the idea. This is Fabian Cohn. He's my colleague. He's a fantastic Go engineer. And he reduced that by a significant amount. He actually made it useful. So what we actually did is we took this model and we just said, hey, let's just write this guy to disk as well. So we don't mess around with clustered sort of database mess or anything. We just, on shutdown, we write a snapshot of the alerts. And on reboot, we try and read that file if it exists. And that's all we did. So how did that work? This is how it looked before. So it's a pretty clear signal, basically. Every time you get this Alertmanager reboot, don't worry about the y-axis, it's kind of weirdly scaled. But you can see on the bottom, the quarantine immediately spikes, every reboot. And this was kind of every Tuesday, by the book, You knew this was going to happen. Now, when we rolled out our patched version of the Alert Manager, we saw kind of 3 different steps. The first was the initial version bump rollout. That caused some noise, of course. This is just showing the total alerts loaded into the Alert Manager. And then, from then on, we were actually able to recover the alerts on disk. And the interesting one is the last rollout, because then everything was kind of fully stabilized. And so when we do a rollout, you can't even tell that the alerts have gone away. And that actually had a very nice effect for us. So you can see here that this was a sort of a more recent, I say August maybe. Yeah, this was a successful rollout. This was a quiet rollout. And overall, I mean, if we just count the total number of alerts that hit the quarantine, it dropped away by 80%. So we do still have some issues. Yeah, but it's kind of nice. So yeah, back to the sort of the title. I need to finish up here. So Alert Manager does have Amnesia, but should we fix it? Kind of 2 pictures that I would put to kind of answer that. The first is a UK child's cartoon. Can we fix it? Yes, we can. We've proven maybe that in our setup, we can fix it, perhaps. But should we? To be honest, the short answer is probably not, because like I say, there are very good design choices why the Alert Manager is built the way it is. So I should reiterate that we built a hacky setup that works for our chaotic and volatile environment. It really is very, very chaotic. It's almost certainly not ready for public consumption, but there is still room for Alert Manager to evolve. So there's some very interesting discussions ongoing at the moment. I know that, I'm not sure if they're here, like Kevin Hellemund from Cloudflare, or Sivash Safi. They're both working a lot on this at the moment. I know Cloudflare has a team who's looking at Alert Manager. And so there's a few ideas going around how to make the reboots more stable, because large environments do seem to suffer from this. And one idea is to make inhibitions part of the gossip. So don't gossip all the alerts, that might just be too much data. But let's say, okay, let's just take the important alerts, the inhibited alerts, and put them in. And there's some links there if you want to go and have a look, and a GitHub issue to get involved. So that's it. Thank you very much for your attention. And I think we have a few questions.
Amazing work. Questions?
Hello. Hello. I'm here.
Hi.
You said that probably it is not worth implementing the saving of state of alerts between Alert Manager restarts. And my question is why?
I would say it's not. Okay, I should caveat that. I was perhaps a bit too harsh on ourselves. So what we did is probably not the way to do it. I would say that. There was a pull request, I think, early days, like 2019, where someone actually added etcd as a backend, like in a shared alerting backend. No?
Yeah, I think that it's too complex to add some it's ACCD.
That was
but it's better to store these states of alerts locally on local disk and then recover.
Yeah. So it could be, I mean, let's say I would like more people to validate what we did, let's say. I think that it looks interesting, but I'm also not 100% convinced that there's not just something weird in our setup, because it is complicated. But yeah, I think that it could be something which could spark a sort of, if somebody else wants to try, we have the code is ready, someone else can patch their system sort of tomorrow if they want to and see if it helps them. That would be really cool actually to get feedback like that. Yo.
So the guiding principle of why the Alert Manager is kind of wacky the way it is because the guiding principle is it needs to survive split brain. Mm-hmm. So if you have an Alert Manager in one continent and an Alert Manager in another continent and they're gossiped, if the gossip fails, each continent can independently notify.
Yeah.
So that's the only guiding principle there and why it's so weird. That said, do you want to become an Alert Manager maintainer?
I took the mic. You go first.
Absolutely. Yeah. Yeah, I think that if any good of this talk comes, it would be great to see a bit more action on the Alert Manager GitHub. So yeah, certainly that would be.
Here, hello.
Hi.
Oh, Ben was faster than I. So what I wanted to say is that being very transparent in the Prometheus team, we are currently lacking expertise in Alertmanager. We have maintainers, but they've been moving around. They have different jobs, different priorities. We don't have many maintainers today. So what can Prometheus team do to onboard you or somebody in your previous company?
Yeah.
And how can we do so we collaborate together instead of like we did something that's incorrect? Let's work together.
Yeah, I mean, that's a good point. I think just probably more active maintainers would help. I know, yeah, like fairy dust right now. I think keeping the dialogue open in the CNCF channel, that of course helps. Yeah.
Are you on CNCF?
Yes.
Test. Awesome. I know we're not supposed to give statements. I wanted to just ask for one quick clarification about the 3 instances sending with this 15 seconds peer timeout. Maybe you meant it like that anyway, but just to clarify, it's not like they take turns every 15 seconds, but it's, as far as I understand, it's always the first instance sending, and then the next one is listening for 15 seconds on the gossip channel to see if the first instance made it. And if it already sees, first instance made it, it will never send.
Okay.
And then the next one waits 15 seconds longer. So the second one, the number 2, will wait like 30 seconds in total. So in the normal case, should always be only the first instance. And then the other ones will learn in time. Oops, yeah, it has already been sent, right, over gossip. And then in the worst case, split brain, network partition, they all don't hear from each other anymore, and you will get 3 notifications if they can still reach you. So that's kind of this fail open model of Alertmanager. Yeah.
That's interesting though, because we see in our metrics, we see that there's like a pretty even, I should probably post it, but there's like a pretty even split in the rate of notifications being sent by every instance.
Okay. I mean, I can also be corrected from the audience if Alertmanager, but that's always been my understanding of it. And yeah. And I checked the code again, and it looks like it is supposed to be like that, but maybe there's a bug also, or in my understanding.
It's more
but
like I'm wrong.
Yeah.
Thank you for the talk. I'm here.
Hi.
It's not a question. I'm just wanted to also share that we're familiar with also such a problem, and what we have found is that there is dirty hack that you can swap basically inhibition engine and ingestion and put 5 seconds in between them in the code, and it will just work.
Okay.
Inhibition just very slow, and there is an open pull request to make inhibition faster, but it's been, a year, I think, in review.
Okay. Yeah, but that's interesting to share those kind of stories, right? I think those would be it'd be really cool to see those kind of hacks coming into the Slack channel and collecting them and trying to build features around them. This would be amazing. Yeah. Awesome.
Let's keep it with questions, not statements. But yeah, it's interesting.
I got 2 statements and 1 question. First, thanks a lot, for confirming my sanity, because for the last 6 months, I thought that I'm just insane and I'm seeing what others aren't seeing.
Assuming I'm not insane.
Second thing is, like all the alert managers are sending the messages regularly. Like they are really, as it was. As it was described with the token, that's at least how we can see it in the metrics. That really all the like there is counter for how many alerts were sent. It's blinking red. Yeah. So and there are even open issues for that on the alert tracker. For.
It's not supposed to be like that.
Yeah.
That's not okay.
That's yeah. You said maybe there is bug. And my question: so currently you are running this in your production?
Yes.
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 And is it stable?
Define stable. Like I said,
It's place for horses.
So I would say yes, it's stable in the fact that we were able to successfully reduce the number of quarantine alerts we have. We don't see any kind of, we don't see, for example, false negatives or this kind of thing, missed alerts. We're quite confident in the system that we have. It's just a bit too noisy. It doesn't like if things change. For example, there are some subtle failure modes, like if with the node restarts, if the ruler is rebooted at the same time as the alert manager, and you have resolved alerts, they get lost also from the ruler resending, which means that you can also lose resolutions. And that's a problem for customers because they don't like it if the ISP line looks like it's been down for 3 days, but actually it was resolved after 5 minutes. So I would say yes, it's stable, but with a very big caveat that I would not be comfortable to roll it out or propose it as a feature in the upstream alert manager until it's been validated by maybe more of the community. Yeah. But if you're asking sort of if you want to run the patch, I would say go for it. Yes. Yeah.
Hi.
Where are you? I can't.
Yeah.
There we go.
Thank you for the talk. We had the exact same issues in production.
Okay.
And we ended up fixing them by adding an additional service to handle the duplicates. But I wanted to ask if you tried adjusting the 3 configurations, the group weight, the interval, and the gossip interval to try to minimize the duplicates. And what are your observations there?
We spent a bit of time doing this, but it's very hard to run experiments in production. And the tricky thing as well is we really struggled to get a development setup that could mimic this behavior. So we haven't spent much time tuning those parameters. We kind of leave those at the defaults, mainly because, like I say, we would have to really mess with production. That could be very noisy, beyond what we're used to. So yeah, but that would be interesting. Like the first thing that we actually spent some time on, like a sprint we spent 2 weeks on, was can we build a dev setup that really mirrors this? And after 2 weeks, we figured, maybe not, because production is just too hard to model. So we stopped that and we focused on what we can kind of treat symptoms-wise.
Hello? The last question. It's not a question, just suggestion. Probably it would be better to just wait after Alert Manager restart for the time which covers all these timeouts, which you configured in the configuration, and do not send any alerts period of time.
You've opened up another thread there, because then the Prometheus operator prevents us from doing that. To have like a min ready seconds, right?
I think that the Alert Manager can automatically determine this time duration while it should not send any alerts until it rebuilds all the alerts in state.
Yes, so you basically build a sleep into the ready check or something.
Yes, something like this.
We did try that. We found it was basically then just too slow because we'd have to, have a sleep of 15 minutes, pretty much. So yeah, I think that was successful as well. But we focused on getting the cluster back as quickly as possible. That was our sort of guiding light there.
All right, we're at time, but I love the momentum and energy around Alert Manager, so we wanted to keep it going, I guess. Please